Alright, gentlemen, so we have the end of term paper 2 for mathematics. I will be doing the solutions. Now, I will be doing the solutions with extra work for you guys, right? So, things like statements, I'll put it in, and I recommend that you all do it as well. So, without any further ado, let's get started. So, number 1, determine the value of 3.29 squared minus 5.5 over so by so. In your exam, you all will have lines to write on, and this is what I recommend you all do. Separate your working as such. So you do working here, coming along the road, and then you draw an arrow and you continue working here, because sometimes the lines are not enough to do your working in. So this is a way you could actually have enough space for working on your exam script. In the solutions, I'll be doing the solutions on the side here. So the first thing I want to calculate is the numerator. So I'll go on my calculator and I'll calculate the numerator exactly as I see it in the question. Open bracket 3.29 close bracket squared, take away 5.5 equals, and I get my numerator. My numerator is 5.3214. 5.3241, sorry. Divided by, and I'm going to work on my denominator exactly as I see it. Now, sometimes some calculators will do this. If I just put square root 1.5 multiplied by 0.06 equals, I'm going to get a number. What my calculator is doing right now, it is just calculating the square root of 1.5, then multiplying it by 0.06. So the answer for this is 0.07 versus the square root of, open bracket, 1.5 multiplied by 0.06 close bracket is equal to, we get 0.3. So please be mindful when you all are working with your calculators. Just to be safe, use brackets as much as you all can. So we get divided by 0.3 is equal to, and this here, 5.3241 divided by 0.3 is equal to 17.747. 17.747, giving your answer correct to 1 decimal place. So for 1 decimal place, I'm going to look at my second decimal place. If it's 5 or more, I'll add 1 to my first decimal place. However, it's not 5 or more, so this remains as 17.7, and you can put an extra statement to 1 decimal place. Next, a metal is made from copper, zinc, and lead in the ratio 13:6:1. So from the time you hear ratio, the first thing you should think about is calculating the total number of parts. So 13:6:1, my total number of parts is going to be 13 plus 6 plus 1. 13 and 6 is 19. 19 plus 1 is 20. The mass of zinc is 90 kilograms. So what we did just now, this is the copper, this is the lead, and this is the zinc. And I'm not labeling these with respect to their elements in chemistry. I just labeled them with respect to the first letter in the element. The mass of zinc is 90 kilograms. Zinc is 1 part out of the total number of parts. So I can say that 1 out of 20 is equal to 90 kilograms. Well, if I know what 1 out of 20 is, I can calculate what 2 out of 20, 6 out of 20, 13 out of 20 is. I could also calculate 20 out of 20, which will be the mass of the entire metal. So 20 out of 20, it's going to be just 90 multiplied by 20, which is 1800 kilograms. And that's the mass of the metal. And that's number 2 done and dusted. What you can say here, you could say mass of the metal. Some of you like to write answer equals, and that is no problem. I tend to stray away from that because the last line of your working should reflect your answer. BDS dollars mean Barbados dollars and EC dollars mean Eastern Caribbean dollars. Karen exchanged 2,000 and received 2,700 EC. calculate the value of 1 BD. All right. So you could create an equation here and say that 2,000 Barbados dollars is 2,700 Eastern Caribbean dollars. I want the value of 1 Barbados dollar, so I'll have to divide both sides by 2,000 to get 1 Barbados dollar on the left. So if I divide this by 2,000 and I divide this by 2,000, I'm going to get 1 Barbados dollar. So 1 Barbados dollar is equal to 2,700 over 2,000. That is just 27 divided by 20, which is $1.35. Please note $1.35 EC. Please note that when it comes to money, money is always in 2 decimal places. So if I had more than 2 decimal places in my answer on the calculator, I would just approximate to 2 decimal places. Next, if Karen exchanged 432 EC for Barbados dollars, calculate the amount of Barbados dollars Karen will receive. Well, if I could figure out how much 1 EC is, I could figure out how much $432 EC is. So I'll perform the same steps above, but instead I'll divide by 2,700. So for part 2, I'll have 2,000 Barbados dollars is equal to 2,700 Eastern Caribbean dollars. If I divide both sides by 2,700, I will get what 1 Eastern Caribbean dollar is. What I'm going to do here, I am going to check and see what 2,000 divided by 2,700 is. Bacchanal. I don't like to represent numbers like this. So what I will do to make myself very, very, very accurate, I'm going to leave 2,000 over 2,700. The 2 zeros could cancel out. This amount of Barbados dollars is 1 Eastern Caribbean dollar. So therefore, 432 Eastern Caribbean will be equal to 432 multiplied by 20 over 27, which is equal to 432 multiplied by 20 divided by 27, $320 exact. If I had used the approximation from before, I will not get exactly $320. 320, what will this be? Barbados dollars. Right, so far so good. And that's number 1 done and dusted. Number 2, we have binary operations to do. And binary operations is real easy. It's just a pattern you just have to follow, and the pattern is literally given to you. A star B is equal to A plus B squared minus 2AB. We want to know what 3 star 4 is. All I'll do is replace A with 3 and B with 4. Minus 2 into 3 into 4. Every substitution, I recommend putting it in a bracket. Even myself, I just want to be 100% sure using my calculator. So 3 plus 4 is 7 squared, which is 49. Take away 2 into 3 into 4. And we get 25. 49 take away 12. 2 3 6, 6 24, 49, yeah, 25. Part B, given that R is equal to that, find out a value of R when P is 6 and Q is 12. Again, this is a substitution question, just like 2 part A. So very, very similar to 2, very, very similar to 2 part A. I'm going to have R is equal to 2, P is 6. So I'll put in 6, which part P is cubed, divided by Q, which is 12, take away 3. My recommendation here again is do not plug this directly into a calculator without putting the denominator in a bracket, or we know the denominator is going to be 9. And I'll illustrate what I'm showing you guys here. 2 into 6 cubed, my numerator is 432. And I know my denominator is 9. I know that for sure. But if students do this, 2 into 6 cubed divided by 12 take away 3, again 33 as my answer, if I plug it in my calculator exactly as I see it on the question. However, 432 divided by 9 is 48. So please be mindful of that little mistake you can make. Alright? The correct thing to do if you are plugging it directly into your calculator is this. 2 into 6 cubed divided by, open bracket, 12 take away 3, close bracket, equals 48. Aha. Factorize completely. Now, the first instinct here is factorize by grouping. But if you try to factorize by grouping, and you can pause the video and try it for yourself, you're not going to get the first bracket and the second bracket being the same thing to perform the factorization by grouping. So what do? We go try something. When in doubt, try something. If you don't know where to start with what you know. Oops, sorry about that, boys. That's end of term 1 solutions. Alright. So I seen x squared minus y squared, and that's a difference of 2 squares. So I go draw a nice neat little working column, and I'll say x squared minus y squared. This is a difference of 2 squares. And factorizing it, I'm going to get x minus y into x plus y. No scene. So my first piece of my working looking like x minus y into x plus y. And I can actually factorize the second piece using 4 as my algebraic factor, and I'm going to get x minus y. Cool. When I expand both sets of brackets, I will get back what I have. X minus y into x plus y will give me x squared minus y squared. Minus 4 into x minus y is going to give me minus 4x plus 4y. Here I could perform a factorization by grouping. X minus y is present in both terms. So I'll factorize x minus y, and I will remain with my x plus y take away 4. If you wanted, you could have put the x plus y in a bracket and take away the 4 last, but it doesn't matter because nothing will be affecting that negative 4 at the end of your brackets. But if you want to leave it like this, you can leave it like this. But ideally, you will want to simplify it as x minus y into x plus y take away 4. Part D. The height h of an object is directly proportional to the square root of its perimeter, p. Write an equation involving showing the relationship between h and p. So the sign for direct proportionality is this. And we know that based on the question, h is directly proportional to the square root of p. Now the question asks for an equation. I do not have an equation here. In order to get an equation, I must change this proportionality sign. To change the proportionality sign, I literally just change it to an equal sign and multiply the right hand side by a constant. Usually the constant is k, so h is k square root of p, and you state where k is a constant. Part B, part 2. Given that h is 5.4 when p is 1.44, determine the value of h when p is 2.89. So the first conditions, when h is 5.4 and p is 1.44, this gives us the luxury to calculate the constant k. So when h is 5.4 and p is 1.44, we'll have 5.4 is equal to k square root 1.44. If I rearrange 5.4 over the square root of 1.44 is equal to k, and I can plug this into my calculator. K is equal to 5.4 divided by the square root of 1.44 is equal to 4.5. Now I can rewrite my equation using the value of k. So therefore, h is actually 4.5 by the square root of p. The question asks now, determine the value of h when p is 2.89. So when p is 2.89, h is going to be 4.5 square root 2.89, which is equal to, jump on my calculator yet again, 4.5 square root 2.89 is equal to 7.65. And we're good to go for part 2. Alright, number 3, I unfortunately pressed record. I forget to press record and I did the solution. So I'll just talk through the solutions for number 3. Part B. Part A and B. So number 3, part A, for our construction questions, my suggestion to you guys is to actually draw a quick sketch of the shape in the question. So in this case, it's a rectangle. So I will draw the rectangle and I will label the rectangle as accurate as I can without putting in any construction lines as yet. So I know what my diagram is going to look like. Now, when I am constructing, I have to show all of my construction lines. That's what you are marked on. Examiners are going to know if you're ratch. Sometimes the ratch does be real good and it's difficult to see. And most of the times the ratch does be ratchy and we could see which part you're ratch. So please make sure and include your construction lines when you are drawing these diagrams, and you will see the construction in a bit. For part B, the curved surface area of a cylinder is equal to 2 pi RH. So they give us information, so I wrote down the information on the right hand side, where R is the radius and H is the height. And the surface area of the sphere is 4 pi r squared. Yet again, I would write down this information on the right. The diagram above, not drawn to scale, shows a solid glass paperweight which consists of a hemisphere mounted on a cylinder. So they gave us the formula for a sphere. A hemisphere is half of a sphere. I don't know if it's going to be useful information to me as yet, but I will still calculate what the area, the surface area of a hemisphere is over here. So I get the surface area of a hemisphere to be 2 pi r squared. The radius of the hemisphere is 3 centimeters, and the radius of the cylinder is 3 centimeters, and its height is 8 centimeters. Calculate using pi as 3.14, and this is very important, boys. If it is a calculate question, and you use pi as pi on a calculator, you're going to lose marks. Because they said they gave us instructions, use pi as 3.14. Calculate the curved surface area of the cylinder. We have the formula. It's just the plug-in values. Get 150.72 centimeters squared. Please input your units. If I had used pi as pi on my calculator, I'm going to get 2 pi into 3 into 8. Which is equal to 150.796 or 150.80, which is, it's quite a bit away from the answer in which they are looking for. All right, this here is the only answer they're looking for using pi as 3.14. So you will lose marks if you put 150.79 or 150.8. All right, this piece here is the last piece, so I will bring this down. Cool. Part 2, the surface area of the hemisphere. So AA, the formula I would have calculated beginning comes into play now. Surface area of the hemisphere is 2 pi r squared, which is 2 pi into 3 squared, which is 56.52 centimeters squared. Again, use pi as 3.14. Lastly, the total surface area of the solid paperweight. Now, some questions guide you and some questions try to trick you. This is one of those questions that tries to trick us. They ask us to calculate 2 surface areas and then ask us to calculate the surface area of the entire shape. But we have to remember this is a solid paperweight. It has a base. So the total surface area will be the area of the hemisphere on top, the curved surface area, plus the area of the base. And the area of the base is just a circle. So the surface area of the paperweight is curved surface area plus surface area of the hemisphere plus the surface area of the base. Plugging your values, I would have plugged in my formula for the area of a circle, surface area of a circle and area of a circle, basically the same thing. And I will get 235.5 centimeters squared. If you want to approximate it, you could approximate it. But make sure when you're approximating it, put in brackets to how much ever decimal places. Alright, so we go here, bam shot. I'll just divide it by 2 because that's what my calculator does. Never mind. 150.72 plus 56.52 plus 3.14 into 9, and I get exactly 235.5, so I don't have to go and put any approximations. Right, and that's it for number 3. Number 4, the functions f of x and g of x are defined as f of x is that and g of x is this. Write an expression in terms of x for f inverse x. All inverse functions questions follow the same steps. First, we will let y be the function. Next, we will interchange x and y, and the interchange sign you can use is an equal sign with half of an arrow on top and half of an arrow below. So this is x interchanged with y. X is 3y plus 2, and the instructions from here is simply solve for y. So I'll get x take away 2 is equal to 3y, and x take away 2 over 3 is equal to y. Your last step is to let f inverse x, or whatever inverse function you are trying to calculate, be equal to x minus 2 over 3. Now there's another way in which this question could have been done, and the other way is if you moved the 3y and moved the x from this line here. So I'll get minus 3y is equal to 2 take away x, and y is 2 take away x over minus 3. Both solutions, are accurate. 2 take away x over negative 3. Write an expression for g f of x in the form x plus a into x plus b, where a and b are real numbers. So let's go. G f of x. I like to put my whole f of x in a bracket. So I know I will just replace f of x with 3x plus 2, which is equal to, wherever I see x in g, I'm replacing it with 3x plus 2. So I see an x squared, so I get 3x plus 2 squared, take away 1, all over 3. Working on my numerator, I think by now, as Form 5 students, you all should be able to expand 3x plus 2 squared very, very easily. This is 9x squared plus 12x plus 4, take away 1, all over 3, which is 9x squared plus 12x plus 3, all over 3. I can divide each term by 3, which will give me 3x squared plus 4x plus 1. And I'll go ahead and factorize this. 3x squared plus 3x plus x plus 1. It have plenty ways to factorize. If you could factorize it in one line, go ahead. I'm using the factorization process where you have a by c, then you get the factors of a by c that will add to give me b, and substitute that into the quadratic. 3x into x plus 1 plus 1 into x plus 1. I'm going to get x plus 1 into 3x plus 1. But the question says, here was the scene. They want x plus a into x plus b. Right now I have the x plus a. That one is a given. But I have 3x plus something. I want x to be by itself. So there is another way in which we could write this. But at this level, I will say leave it like this because the question should have stated cx plus b or bx plus c. So the question should have stated x plus a into bx plus c, right? But in the event that we have this here to do, let's see how to do it. I can rewrite 3x plus 1 differently, and it will mean the exact same thing. So if I take a little side note, a little sidetrack here, if I solve this quadratic, I'm going to get x plus 1 is 0, and I'm going to get x is minus 1, and I'm also going to get 3x plus 1 is 0, and 3x is minus 1, and x is equal to minus 1/3. Now, if I work backwards for my first piece here, if I work backwards, I will move the minus 1 on this side. So if I have a solution for a quadratic and I just rearrange that last line, I'm going to get my x plus 1, which would have been here. And I'm going to do the same thing right over here. I'm just going to move the minus 1/3 on the next side, and I get x plus 1/3, which will correspond to this. So both of these here, they mean the same thing. So what we can do here, this is x plus 1 into x plus 1/3. They mean the same thing. Is of the form, and this is where your statements come into play, x plus a into x plus b, where a is 1, b is 1/3, where a and b are real numbers. And your statements and questions, they actually contribute to getting all A's in your profile. And that's what everybody does strive for. Part B. The coordinates of L, M, and N are 4, 2, 12, 5, and 1, 3 respectively. Calculate the length of Ln. So the length of Ln symbolized as the modulus of Ln. So the modulus is just two straight lines, and you put the name of the line in between those two straight lines. So if I want the length of AB, this is how I will symbolize it. Modulus of AB is equal to, put in your formula. It's x2 minus x1 squared plus y2 minus y1 squared. Now we have to label x1, y1, and x2 and y2. So what I recommend you all do is write down what L and N is and label it. So L is 4, 2, and be careful, N is 1, 3, and be careful. Let this be x1, y1, let this be x2, y2. x2 minus x1 squared plus y2 minus y1 squared. 1 minus 4 is minus 3, and minus 3 squared is 9, plus 3 minus 2 is 1, 1 squared is 1, and I'm going to get the square root of 10 units. For those of you all who want to go and calculate the decimal equivalent to this, no problem with that. Square root of 10 is 3.16 units, but we make an approximation, so you have to put the approximation in brackets to 2 decimal places. Next, they want the gradient of Lm. So again, I will label L, which is 4, 2, and this time I'll label M, which is 12, 5. I'll label it as x1, y1, label you as x2, y2. The gradient of Lm, symbolized as M, and I put a subscript Lm to name the line, is equal to y2 minus y1 over x2 minus x1, y2 minus y1 over x2 minus x1. 5 minus 2 is 3, 12 minus 4 is 8, so 3 over 8, we're good to go. Please, for coordinate geometry, we do not like decimal places at all, at all, at all. So refrain from using decimal places in your answer. Lastly, the equation of the line passing through N and parallel to LM. So in order to get the equation of a line, I need one point on the line and I need the gradient of the line. So do I have the gradient of the line parallel to LM? I do. So what I like to do here, I like to make my statements work for me. So I'll start off my question with, let the line passing through N and parallel to LM be, I will label him L1. I'll name the line L1. Now I can say the gradient of L1 is the gradient of LM, and I'll put in brackets because parallel lines have the same gradient. So the gradient of L1 is actually 3 over 8. Equation of L1 now. So you see how L1 working for us? Instead of writing the equation of the line passing through N and parallel to LM, I could just say equation of L1. And I'm going to write down the point that I'm using. I'm using the point N. N was the last point in the question, which will be 1, 3. 1, 3. Y minus y1 is m into x minus x1. And this is the equation, the formula I will use to calculate equation of lines. If you want to use y is mx plus c, plug in your points and calculate c, no problem at all. We will get the same answer in the end. This is my x1 and my y1. Y minus 3 is 3/8 into x minus 1. I'll expand and rearrange one time. Y is 3/8 x, take away 3/8 plus 3. Y is 3 over 8 x minus 3/8 plus 3 is 2 and 5/8 or 21 over 8. Is of the form y is mx plus c, where m is a gradient, which is 3/8, and c is the y-intercept, which is equal to 21 over 8. So although the question never asked me to express the equation in the form y is mx plus c, I will oblige and do it. Right, and that's number 4 done and dusted. All right, number 5. The diagram below shows the triangle PQR and its image P prime, Q prime, R prime. State the coordinates of P and of Q. So the coordinates of P is going to be 2, 1. So I'm going to write this one here. And the coordinates of Q is going to be 4, 3. An easy one mark. Describe fully the transformation that maps the triangle PQR onto the triangle P prime, Q prime, R prime. Well, the transformation looks like it is a simple reflection. But you can't just say it's a reflection. They had to describe the reflection completely. So the triangle PQR is reflected in the x-axis to give the image P prime, Q prime, R prime. Another way I could have described this transformation is saying it's reflected in the line y is equal to 0. That's accepted as well. Yeah, and that's it. As easy as it is. Write the coordinates of the images of P and Q under the translation 3, -6. So undergoing a translation, we need to first change the coordinates into vector form and then add it to the translation vector. So I can say from P to coordinates of the images of P and Q. So I'm not going to use P prime, I'm going to use P double prime. We will use the formula 2, 1 plus is equal to the translation vector 3 minus 6, which is 2 plus 3, which is 5, 1 minus 6, which is minus 5. But this here is a vector. I need the point. This is 5 comma minus 5. And from Q to Q double prime, so what I'll do, I'll say let P to P double prime and Q to Q double prime be such that it passes through the translation vector. So Q will be 4, 3 plus 3, -6 to give me 4 and 3, 7. 3 minus 6 is minus 3. And I'm going to get 7 minus 3 as the coordinates of the image under the translation. The diagram below, not drawn to scale, shows parallelogram EFGH, in which EF is 6 centimeters, okay, good, EH is 4.2, okay, good, and angle FEH is 70 degrees, good. Calculate the length of the diagonal HF. So this is by no way a right angle triangle, so I cannot use Pythagoras' theorem, and I cannot use sine theta, cos theta, and tan theta, which is opposite, adjacent, and hypotenuse, the ratios. I cannot use that. That's only for right angle triangles. I can use sine rule and cosine rule. This particular question satisfies the cosine rule because I have two sides and the angle between the two sides. So I can use the cosine rule to calculate the length of the missing side. So I'm going to let the diagram, I'm going to label my diagram. This is going to be little e, this is going to be little h, and this is going to be little f. So I'm going to say, using the cosine rule, E squared is equal to f squared plus h squared minus 2fh cosine of capital E. So E squared is equal to f squared plus h squared minus 2f h cosine of 70. So E squared is equal to, I'm going to work out this whole thing on my calculator, and I'm going to actually square root it one time, right? So what shall I do with my calculator at least? 4.2 squared plus 6 squared, take away 2 into 4.2, close bracket, into 6, close bracket, cosine of 70. Make sure your calculator is in the degrees function, is equal to 36.4, tra-la-la-la, and I'm going to square root this. So my square root of the last answer displayed on my calculator will be 6.03. So E is 6.03 centimeters, and I'll put in brackets to 2 decimal places. The area of the parallelogram EFGH. So the area of the parallelogram EFGH, the parallelogram, because it is divided into two equal triangles by the diagonal, if I calculate the area of one of the triangle and multiply it by 2, I'm going to get the area of the entire parallelogram. Cool? So I can say that the area of EFGH is equal to 2 multiplied by the area of EFH, which is 2 multiplied by, one of the formulas I'll use for the area of the triangle is a half AB sine theta, In this case, it's going to be a half FH sine of E, which will just be a half by 2 is just FH sine E. Looks kind of weird, but that's because of the labeling. F is 4.2, H is 6, sine of E is 70. 4.2 by 6 by sine of 70 is 23.68 centimeters squared, again to 2 decimal places. That's it for number 5. Here we have number 6. The table below shows the number of cars in hundreds sold in a country from 2010 to 2014. So we have the little diagram here, the year, how many cars were sold in the hundreds. So there's 1900, 1000, which is 1000, 2600, 1600, 3000, which is 3000. Complete the line graph above to represent the data, the given information. So from what I'm seeing, in 2010, they would have corresponded to 19. And you all will be able to pick this up and bring it closer to your face. So in my case, I'll just zoom in. Go down. All right. So I'll zoom in, and it looks like 15, 16, 17, 18. Every 2 dashes or every 2 lines on my graph paper represents 1 car or 100 cars. So right now we have up to 2012. In 2013 we're looking at 16. So I'm looking at 15, and every 2 dashes is 1. This year is going to be 16. So I'll go across in 2012, well 2013, right? Yeah, in 2013 that corresponds to 16. So in 2013 this is 15, this is 16 here. And in 2014, that corresponds to 30. So that one is an easy one to do. 2014 will correspond to 30. Now, you should use a ruler and draw these things in, but I'm going to draw it in freehand just for now. You're stopping down there, we're not dipping under. And from here, we're going up to there. Right? And that's it for your diagram. Make sure and draw these things with rulers, please. Between which 2 consecutive years was the greatest increase in cars sold? Now, consecutive years means 2010 and 2011, 2011 and 2012, 2012 and 2013, 2013 and 2014. They are not looking for the difference between 2010 and 2012. So from the graph, you could just check and see which one will give the greatest increase. From 2010 to 2011, that was a decrease. So it only has 2 increases here. The increases were from 2011 to 2012 and from 2013 to 2014. So if I look over here, the increase from 2013 to 2014, I'll draw it down here, increases are from 2011 to 2012 and from 2013 to 2014. The increase from 2011 to 2012, and you can represent your information like this when you are working it out. You could draw a little arrow underneath. It will be 2600 minus 1000, which will give me 1600. And the increase will be 3000 minus 1600, which looks like a bit of 1400. So the greatest increase in cars sold, and you write a little statement, the greatest increase in cars sold was between 2011 and 2012. What is the total number of cars sold in the 5-year period from 2010 to 2014? 2010 to 2014, we just have to add up each one of these numbers. So total number of cars sold, it's always good to write statements. Total number of cars sold putting it up here, it'll be 1900 plus 1000 plus 2600 plus 1600 plus 3000. Right, bring this fella down the road. Jump on the calculator. 19 plus 10 plus 26 plus 16 plus 30, 100 and 100. That's 10,100 cars. The mean number of cars sold from 2010 to 2015 was 22,500. How many cars were sold in 2015? So the mean was 22,500. So 100 multiplied by 100, 22.512. Bam, 2250 was the mean. And the mean was from 2010 to 2015. However, I have from 2010 to 2014. And if we know anything about the mean, which is represented as x bar, is the sum of all the x values divided by the number of values, or the sum of all the frequencies, which is equal to, we have the sum of all the numbers here. Now, if I let the number of cars sold in 2015 be, let me say, y, then 10,100 plus y divided by the number of years, and the number of years for this time period here will be 2010, 2011, 12, 13, 14, 15. 6 years. The mean was 2250. Just a little rearranging, 10,100 plus y is 2250 multiplied by 6, 13,500, and y is 13,500. Take away 10,100, and we get 3,400. So therefore, closing statement, the number of cars sold in 2015 is 3,400 cars. Good to go. All right, number 7. For these questions, please read the information you get in the question. A sequence of figures is made from joining polygons with sides of unit length, which means the length of these polygons, the sides at least, are 1 centimeter or 1 unit in length. The first 3 figures are drawn in the sequence below. Now figure 4, I'm not going to be able to draw it as accurate as I would want to, but when you all are drawing it, take your ruler, measure 1, 1, 1. You measure in half here, and you're going up and down. Cool? And rinse and repeat for 4 figures. 1, 1, measure your half, up, down. 1, 1, measure your half, up, down. 1, 1, measure your half, up, down. Alright? So my figure will not be as accurate as it should be, but you will lose marks if you don't follow the pattern in these questions, right? Having the pattern down is one thing. Another thing is having the measurements or the dimensions correct. Study the pattern in each of the rows of the table below. Each row relates to one of the figures in the sequence on page 16. Some rows have not been included in the table. So this is what I recommend for our patterns questions. Just focus on what the name of the headings are. Number of outer lines of unit length and the perimeter. Now, if you want, you can check and see what is the actual pattern in the question. And the pattern is quite self-explanatory. So for figure 1, I'll have 1 plus 2 plus 2. For figure 2, I'll have 2 plus 2 plus 4. For figure 3, I'll have 3 plus 2 plus 6. So what I'm seeing here, I am seeing a pattern, and I'm seeing that how this middle number is the same thing coming down the road. This number here corresponds to the figure number, and this number here, it looks like the first two numbers multiplied by each other. So for 6, I'm going to have 6 plus 2 plus 12. These numbers here are looking like I just added up all these numbers here. So 6 and 2 plus 12, 6 and 2 is 8, 8 plus 12 is 20. We're good to go. For 65 now, I don't know how to work out the 65 piece. So before you actually work out the perimeters, we need to figure out what is figure number n and try to figure out the number of outer lines of unit length and the perimeter in terms of n. Well, if this n, this could be n plus 2n plus these two multiplied by each other is going to be 2n squared. Then my perimeter, it's going to be 3n plus 2n squared. So I know that out for 65, this here is equal to, when I add them up, it's equal to 65, and I could figure out what n is. So for 65, I'll have n plus 2n plus 3n squared, sorry, 2n squared is 65. I get 3n plus 2n squared is equal to 65. Oh shucks, why did I have n in the middle there? My bad. N plus 2 plus 2n. So that's going to be 2n. N plus 2 plus 2n is 2 plus 3n. Good. So we have 2 plus 3n is equal to 65. 3n is 65, take away 2. 3n is equal to 63, and n is equal to 21. So for this shape number, we have n is 21, and we will have 21 plus 2 plus 42. And we're good to go. We already figured out the n part. Show that no figure can have a perimeter of 100 units. Two ways I can do this. I can calculate the figure number that has probably a number before 100 and a number after. The next figure number will have a number after 100, or you could do it by trial and error. Or you can say that out the perimeter, if 2, let 2 plus 3n be equal to 100. 3n go be 98. N go be 98 divided by 3, which is not a whole number. 98 divided by 3 is 32.667. However, n represents the figure number, so you put in a little statement here. Since n is the figure number, n cannot be 32.667. Therefore, no figure can have a perimeter of 100 units. Another way is you could say, well, here was the scene. Let n be equal to, let me try 32. If n is 32, the perimeter going to be 2 plus 3 into 32, which is equal to 32 by 3. I like to work it out on my calculator just to make sure. 96 plus 2 is 98. And let n be 33. The perimeter is equal to 2 plus 3 into 33. 99 plus 2 is 101. And you can say that how, since based on this information, you can make a conclusion, and there's no figure that has a perimeter of 100 units. Right, and that's it for number 10. That's it for number 7. Alright guys, on to section 2. The diagram below shows the graph of 3 lines a shaded region S defined by three inequalities associated with these lines. The inequality associated with the line y is equal to 3 is y is greater than or equal to 3. And we can see this from the line itself. If the line is a solid line, then the inequality will have an equal to attached to it. If the line is a dotted line, then the line will have a less than or a greater than a sign attached to it. For example, if I were to show you guys, just to illustrate, if I have a line, y is strictly more than 5, you realize this line is represented by a dotted line. If I have another line, let's say y is less than or equal to, let's say 2. This line is a solid line. And it works for inequalities where we have strictly less than or strictly more than or equal to. Once it has an equal to sign attached to it, it's a solid line. So these other two lines will also have an equal to sign attached to it. State the other two inequalities which define the shaded region. Well, for each of the inequalities, for each of the equations, sorry, we can test a point. And a nice point to test is going to be 0. For x is equal to 2, the shaded region is in this direction here. So it's very, very clear-cut that the inequality that satisfies that region is going to be x is more than or equal to 2. Now, by assumption, it's a good assumption, but not always an accurate assumption, to say that our x plus y is less than or equal to 10. Not all the time this works. So we have to test a value. Let's test the point 0, 0. In my working column, I'm going to test the point 0, 0. You have a x and you have a y. Plugging that into x plus y is equal to 10. I'm going to leave out the equal to sign and I'm just going to put 10. 0 plus 0 and 10. Now I can figure out what sign goes in the middle. A less than sign goes in the middle. And because the line is a solid line, it's going to be less than or equal to in the middle. So the next inequality is x plus y is less than or equal to 10. The function p is 5x plus 2y minus 3 satisfies the solution set represented by the closed triangular region. Identify three pairs of x, y values for which p has a maximum or a minimum value. So all they want you to do is list the three vertices of the triangle, and this is a common question. They could ask it in a number of ways, but maximum or minimum values when it comes to linear programming, you look at the vertices of the shape that satisfies the shaded region. So the three vertices are 2, 3, that is 1. So I can say 2, 3. Or another point is 7, 3. Or another point is 2, 8. Which pair gives a maximum value for p? Justify your answer. We need to check all three values. Ain't no two ways about it. Check all three values in p. So we will test the point 2, 3. I'll have p is equal to 5 into 2 plus 2 into 3, take away 3. 10 plus 6, take away 3, I'll get 13. I'm going to test 7, 3. I'll have p is equal to 5 into 7 plus 2 into 3, take away 3. 35 plus 6, take away 3. 35 plus 3 is 38. And my final test is going to be 2, 8. P is equal to 5 into 2 plus 2 into 8 minus 3. 10 plus 16 take away 3, that is 10 plus 13, which is 23. So it could be a very, very common misconception that 2, 8 is going to be the maximum because it is the highest point on the graph. But it's not like that. So I can say therefore 7, 3 makes P a maximum. And similarly, 2, 3 makes P a minimum. Part B. Monty is cycling at 12 meters per second. After 4.5 seconds, he starts to decelerate, and after a further 2.5 seconds, he stops. The speed time graph is shown below. Okay, cool. The constant deceleration. Now, deceleration is not going to have a negative sign attached to it. If I have acceleration is -2, that means the deceleration is 2. The acceleration for a speed time graph is just the gradient of that part of the graph. So if I let the graph be such that I have A, B, and C, I can make an easy reference to the graph. I can say the gradient of BC is the acceleration of BC, which is equal to, it have a couple formulas we know for gradient. Vertical distance over horizontal interval, or we can have y2 minus y1 over x2 minus x1. In this case here, the vertical distance is 12 over the horizontal interval from here to here is going to be 7, take away 4.5, which is 3.5. Working this out, 12 divided by 3.5 is 3.43. Now this particular graph goes in this direction here, so I know that the gradient of that line is going to be negative meters per second. Now this is the acceleration. Therefore, the deceleration is equal to 3.43 meters per second. Monty's average speed over the 7 seconds. So the average speed is the total distance traveled, speed is the total distance traveled. Your formula is very important, divided by, oh good lord, divided by total time taken. The total distance traveled is going to be the area under the graph, and the total time taken looked like 7 seconds. So my arrows will guide me as to which part my next piece of working is going to be. Area underneath this graph is the area of the trapezium, which is 1/2 the sum of parallel sides multiplied by the perpendicular distance between them. And this is the formula for the area of a trapezium. Divided by 7. Sum of the parallel sides is going to be 7 plus 4.5. And the perpendicular distance between them is 12 divided by 7. Let's see what the numerator is. 1/2 into 7 plus 4.5 multiplied by 12. 69 divided by 7 is 9.857 meters to 3 decimal places. Meters per second, sorry. Meters per second to 3 decimal places. And we're good to go for number 8, I believe. Good to go for number 8. Alright, resuming where we left off. I got cut off just now. The angle made between a tangent and a chord is equal to the angle the chord subtends to the circumference in the alternate segment. segment. Now, I could actually calculate what theta 3 is. Theta 3 is equal to 180 degrees take away 58 degrees plus 90 degrees. And the reason for that is angles in a triangle are supplementary. So theta 3, which is equal to theta 2, is equal to 180 minus 58, take away 90, and I get 32 degrees. Let's see what else I can see in the diagram. Well, if u is, I have theta 2, theta 1. I could actually calculate this angle here, which is going to be theta 4. Theta 4 is equal to 180 degrees. Take away, no, I lie. I thought that was a cyclic quadrilateral, my bad. 1, 2, 3. Yeah, it is. Right, 180 take away 58 degrees, because angles in a cyclic quadrilateral are supplementary. So 180 take away 58 degrees. 180 take away 58 is 122 degrees. And because I get this as 122, I can actually calculate what theta 5 is. So theta 5 is equal to 180 take away 122 degrees. And this will just give me 58 degrees. And the reason is angles in a straight line are supplementary. Now, the question is, when do I stop looking for theorems in the circle? Well, you stop when you literally can't see any more theorems. Now, I could calculate this angle inside of here. If I zoom in a little bit, I could calculate this angle, and I'll call this angle theta 6. Now, on your paper, it will be easier to identify theta 6. If you want, you could have called theta 6 angle MCN and put the angle on the C. That will give me theta 6 as well. This is another way in which we can name the angles in the circle. So, oh Lord Father, I'll oblige and I'll call the angle M, angle MCN. So MCN is equal to 180 take away theta 5, which is 58 degrees, plus 90 degrees, which is equal to 180 take away that 32. 180 take away 58 take away 90 is 32 degrees. Good. And I don't need to put a reason because I already put the reason. Angles in a triangle are supplementary. So I think we do more than enough. Let's go into the questions and see what they want. And the good thing about it now, we don't have to write down the reasonings in the question. All the reasonings are on the side. Determine the value of each of the following angles, giving a reason to support your answer. Angle A, B, C. That is theta 3. So I could say A, B, C is theta 3. We already calculated theta 3. That is 32 degrees. Good to go. CMB. Angle CMB, that is theta 4. CMB is theta 4, and theta 4 we worked out to be 122 degrees. NCM, that is what we now calculate here, that is the same as MCN, and NCM is the same thing. So NCM is 32 degrees, and we already gave all the reasons above. Are we good to go for that question? Part B. The figure below, not drawn to scale, shows a circle with center O. The radius of the circle is 21 centimeters and the angle HOK is 40 degrees. In this case, opposed to the question way back when, use pi is equal to 22 over 7. The area of the minor sector, HOK. So we know that the area of a sector is equal to area of the circle multiplied by the angle over 360 of the sector, which is 22 over 7 multiplied by r squared will be 21 squared multiplied by, I could put it in a bracket, 40 over 360. On the calculator, 22 over 7 multiplied by 21 squared multiplied by 40 over 360, we get 154 exactly. Is it in centimeters? It is in centimeters, centimeters squared. The area of the triangle HOK, area of the triangle is 1/2 AB sine theta, and you could put where A and B are any two sides and theta is the angle between those two sides, between A and B. Well, we actually have two sides, which is 21 and 21. These two sides here, and the angle between those two sides is 40. So we're going to have 1/2 21 by 21 sine of 40, and this will give us the area of the triangle. 1/2 21 21 sine 40, 141.735 centimeters squared to 3 decimal places. The area of the shaded segment, easy peasy. Area of the shaded segment is the area of the sector. Take away the area of the triangle, which is equal to 154. Take away 141.735, which is equal to 154. Take away 141.735, 12.265 centimeters squared to 3 decimal places. If you wanted to work to 2 decimal places, no problem with that. It's all up to you. Right, and that's it for number 9. Alright, boys, home stretch. Number 10. The diagram below shows a triangle OPQ in which OP is 3U, OQ is V, Q is the midpoint of OR, so observe the diagram and see where the information falls into the diagram. Since Q is the midpoint of OR, then this is also a V here. M is the midpoint of PQ, sorry. Okay, good. And L is on OP such that OL is 2/3 OP. So they actually give us a real good piece of information here. Very good piece of information. Write in terms of U and V an expression for LM. So LM is L something plus something M. And we're looking for a letter in common with L and M. So I can go with LP and PM. LP will be a third U. Yeah, LP will be 1/3 of OP, and OP is 3U. So let's write it down. LP is 1/3 of OP plus, no, LP is just U. Okay, we have it in the diagram. LP is U plus PM. I need to figure out what PM is. So PM is 1/2 PQ. We had to figure out what PQ is. PQ is PO plus OQ. And we have that information at the ready. This is minus OP plus OQ, which is minus 3U plus OQ is V. So PM is actually 1/2 of minus 3U plus V. So U plus minus 3 over 2U plus 1 over 2V, which is equal to 1 plus negative 3 over 2U, which will give us minus 1/2 U plus 1/2 V. Good. That's LM. Next, we want PR. PR is just PO plus OR. PO is negative OP plus OR. That's minus 3U plus 2V. Cool. Using a vector method, prove L, M, and R are collinear. So L, M, and R, draw a straight line, L, M, and R, and pick any two vectors on this straight line. Let me pick two vectors that we have. We have LM. Do we have MR? No, we don't. Can we get MR? Kind of difficult. Can we get LR? Still kind of difficult. So let me go with the MR now. And MR. Now, I have LM. Let me try and figure out what MR is. MR is MQ plus QR. So MR is, let me put this one side now. I gotta write out what LM is just now. MR is MQ plus QR. MQ is 1/2 of PQ. Plus QR is just V. This is 1/2 of PQ, which is 3 minus 3U plus V plus V minus 3 over 2U plus 1/2 U plus, sorry, 1/2 V plus V, which is minus 3 over 2U plus 3 over 2V. And I could factor this out and say this is 3 over 2 into minus U plus V, or V take away U. And LM is minus 1/2. I could factorize LM as 1/2 into V minus U. So there's MR. Now watch what I can do here, right? If I can show that LM and MR are parallel, they will have a common point M, hence they will be collinear. So I'm going to do a little bit of algebra here. I can say from LM, I can say 2LM is equal to V minus U. I could do that. Now I can say MR is equal to 3 over 2. V minus U is 2LM. So MR is equal to 3 over 2 multiplied by 2 is 3LM. So I can say MR is parallel to LM since LM is a scalar multiple of MR. MR and LM have a common point M. Therefore, M, R, and L are collinear. Bam shot. We're good to go for that one. Alright, last piece now. Write down a 2 by 2 matrix R, which represents reflection in the y-axis. So we could say R is equal to -1, 0, 0, 1. Write down a 2 by 2 matrix which represents a clockwise rotation of 180 degrees. So N is equal to cosine theta minus sine theta, sine theta, cosine theta. Cosine of 180 is 0. No, cosine of 180 degrees is -1. Sine of 180 degrees is 0, 0, 1, -1, sorry. And write a 2 by 2 matrix T, which 3 units. So we get -3, 5. Nice. And the point, well, P is the point 6, 11. The point P undergoes the following transformations such that RNP maps P to P prime and NTP maps P to P double prime. So if Rn on P will take P to P prime, I can say Rn on P is equal to P prime. So R, which would have been -1, 0, 0, 1, N, which would have been -1, 0, 0, -1, and the point P in vector form, which will be 6, 11, will be equal to P prime. Matrix multiplication like this will take place from the right to the left. So we will multiply these two matrices first, or perform the transformation on these two first, which will be a rotation on the point 6, 11. And the rotation will give us bam, 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 -6, -11. So -1, 0, 0, 1 on -6, -11 is equal to P prime. And then perform this matrix operation and we will get 6, 11. And in coordinate form, we're going to get 6, 11. In a similar step, NT on P will be P double prime. So N, which is -1, 0, 0, -1, T, which is -3, 5 on the point P, will give me P double prime. Performing this matrix transformation first, this will be a translation. So we will just add the matrices together because I'm performing a translation on the point P. Translating the point P, I'm going to get, I'll write in the back this one. I'm going to get -3 plus 6 will give me 3. And 5 plus 11 will give me 16. I'll get -3 minus 16 when I multiply the matrices to give me P double prime, which is -3 minus 16. All right, so if you all have any questions on this paper, please voice them in the comment section. I will post the AdMaths one probably tomorrow, and it's good to do the solutions to these answers ASAP. Look out for the paper 2023, paper 1. I recently got the paper 1, so I will do the solutions for that for AdMaths and post it up. And if you all have any questions on any topics that you all would like to cover, just voice them in the comment section, and we will see how best we can facilitate videos to address the topics that you all will be getting problems with for both maths and AdMaths. Alright boys, so good luck. Please keep studying hard. Exams is literally right around the corner, and hopefully I will see you guys very, very soon.